let's try another one. I'm going to get you started on this one and then let you continue it and finish it out. So the first thing I notice is that the 3 here doesn't even have a denominator. But remember that anything that is an integer can be written as a fraction by putting it over 1. So now that just visually makes me feel a little bit better. The second thing I notice is that I have a linear factor, but I have quadratic here. And so I need to think about what to do to simplify that and factor it. Well, I notice that this is a difference of 2 squares because I have a negative sign, a minus here, a difference. X squared is a perfect square of x. So I will write an x in the front. 1 is the perfect square of 1. So 1's in the back. Plus and minus. And now that everything is broken down into linear factors, I can go ahead and determine my LCD. So my LCD, I see an x plus 1 in the first fraction, another x plus 1 here, but remember I don't have to write it if it occurs in the next fraction, and then an x minus 1. The fact that I have a 1 here isn't really going to make a difference because if I multiply everything through by 1, I'm still going to get this. So let's go ahead, and I would like for you to continue from here. So what you need to do is decide what to multiply each fraction by, if anything, in order to make it x plus 1 and x minus 1. And then continue solving from there. Remember that you'll be able to cross out your denominator, and then you will combine some like terms, move things around to be able to continue solving. Once you've done that, come back here and let's see how you did. All right, let's go ahead and walk through this. So for the first one of our expressions, I have an x plus 1, but I need an x minus 1. So I'm going to multiply top and bottom by x minus 1. The second one, well, I already have both pieces. I have x plus 1 and x minus 1, so that doesn't need to get multiplied by anything. And then the 3, well, I don't have either piece. I just have a plain 1, so I need to multiply by both pieces, x plus 1 and x minus 1, or you could have written it a little more condensed as x squared minus 1 over x squared minus 1. Remember that those are equivalent. We already talked about x squared minus 1 being this in factored form. And it honestly does not matter which version of the LCD you write. Whenever you rewrite everything, notice that I use the x squared plus 1 version, but we're going to cancel it here in a minute, so you might as well save yourself a few pen strokes. All right, let's go ahead and look at our next step. So our next step is to multiply everything and start simplifying. So I'm going to multiply x minus 1 times 4x plus 1 here, and I'll actually do that multiplication in the next step. This fraction stays exactly the same as it was. I didn't have to multiply by anything. And then 3 gets multiplied by x squared minus 1, or times x plus 1, x minus 1, and top and bottom. I can now cross out my denominator just like I did before, because I know if I multiplied both sides by an x squared minus 1, those would cancel just like they did in the previous examples. So let's start working on this. I want to multiply x minus 1 times 4x plus 1. So I'm going to have x times 4x, 4x squared. And then negative 1 times 4x, negative 4x. X times 1 is an x, and negative 1 times positive 1 is a negative 1. On this side, I'm going to have 12 here, and then 3x squared, and then 3 times negative 1 is negative 3. Let's combine like terms. So I can combine negative 4x and x to negative 3x, and I can combine 12 and negative 3 to be 9. go ahead and move everything from this side over. Remember, we want to keep the a value as a positive 1 anytime we can. If we had moved the negative or the 4 to the other side, I would have had a negative 1 and I'd have to use guess and check factoring. Let's not get into that until we have to. By the way, we're going to have to in the next problem. All right, so now that we have our positive 1 here, we can just do factors of negative 10 that add to be negative 3. And that will be negative 5 and 2, giving me final x values once I solve each of these little equations of x equals 5 and x equals negative 2. Taking a peek back at my LCD, I want to determine what x should not be to keep the denominator, any of the denominators from being 0. I'm going to get a negative 1 here, because if I plugged in negative 1 plus 1 would be 0, and a positive 1 here. So overall, I have a positive and a negative 1. Neither of these values is positive or negative 1, so I'm good.